The sun, a massive ball of fire, burning at an unimaginable 15 million degrees Celsius at its core. But wait, fire needs oxygen, right? So how does the sun keep burning in the vacuum of space, where there's no oxygen at all? Today we're diving deep into the science behind this cosmic mystery. Stay till the end, because the answer might surprise you. When we think of something burning, we imagine fire, the kind we see in campfires, candles, or explosions. This type of fire is called combustion, and it requires three things. 1, fuel, like wood, gas, or coal. 2, heat, a spark or high temperature. 3, oxygen, to sustain the reaction. On Earth, fire happens when oxygen reacts with a fuel source, releasing energy in the form of heat and light. That's why fire goes out in space. There's no oxygen to keep it going. But here's the thing. The sun isn't burning in the way a campfire does. It doesn't rely on oxygen at all. Instead, it's powered by something far more powerful: nuclear fusion. Deep inside the sun, at its core, the pressure is over 250 billion times greater than Earth's atmosphere. The temperature, a mind-blowing 15 million degrees Celsius. At these extreme conditions, a completely different process takes place: nuclear fusion. Instead of burning fuel with oxygen, the sun fuses hydrogen atoms together to form helium. This process releases an enormous amount of energy, which travels outward and eventually reaches us as sunlight and heat. So how does nuclear fusion actually work? 1, the sun is mostly made of hydrogen, the lightest element in the universe. 2, due to intense pressure and heat, hydrogen atoms smash into each other at high speeds. 3, when they collide, they fuse into a new element, helium, and in the process, a tiny bit of mass is lost. 4, that lost mass is converted into pure energy thanks to Einstein's famous equation, E equals mc to the power of 2. This process releases an unbelievable 386 billion megawatts every second, enough to power millions of Earths at once. Now, if the sun doesn't need oxygen to burn, does that mean it will last forever? Sadly, no. The sun has been fusing hydrogen for about 4.6 billion years, and it's only halfway through its lifespan. Eventually, it will run out of hydrogen fuel and start fusing heavier elements like helium and carbon. In about 5 billion years, it will expand into a red giant, swallowing Mercury and Venus, and maybe even Earth. But don't worry, we won't be around to see that happen. Here's a crazy thought. What if the sun actually burned using oxygen like a giant campfire? Well, if that were the case, the sun would have burned out in just a few thousand years, a blink of an eye in cosmic terms. Instead, thanks to nuclear fusion, the sun has been providing light and warmth for billions of years and will continue to do so for billions more. So, to answer our big question, the sun doesn't actually burn in the way we think of fire. Instead, it shines because of nuclear fusion, a process that releases energy by fusing hydrogen atoms together under immense pressure and heat. Without fusion, life on Earth wouldn't exist. No sunlight, no warmth, no plants, no humans. So next time you feel the sun's warmth on your skin, just remember it's powered by the same force that lights up the stars across the universe. If you enjoyed this video, make sure to like, subscribe, and hit the notification bell so you never miss out on more mind-blowing science. What other space mysteries do you want us to explore next? Let us know in the comments below.